We are at Point One Manufacturing.
Yeah, P1 Manufacturing.
And they make some really cool stuff here. It's a big ass building. What do you guys make here?
Fasteners, basically. And
that's
some,
boring.
Cool,
boring. Nuts and bolts, boring.
We make cool billet aluminum top fuel blocks too.
There you go. They make top fuel blocks here. So, but also the nuts and bolts they make are pretty sweet too, from what I hear. So Mark is going to give us a tour of the facility and show us how the stuff's made, and also show us a big open area that like he just drops like little teasers of what the future may hold for what gets made here somewhere along the line. So
exactly.
Thanks for having us, and let's go check it out.
Yeah. The ones that are running like this past weekend, for example, Antron Brown definitely has a bunch of our blocks in there. Sean Reed just bought a bunch
Toyota
of
blocks here.
Yeah, those are Toyota, they're Ford, they're Chevrolet, a little bit of everything. Cruz Pedregon has some of our blocks. Matt Hagen has some of our blocks. So there's definitely, and there's a lot of other ones that are out there too in the non-NHRA world as well. Because I mean, a lot of these blocks will end up in tractor pulling or in top fuel boats or in all kinds of different things. But
now, is that the only block you make right now? Is it Hemi?
That is the only block that we make. Yes.
Cool. And heads? Yeah. No heads?
No heads at this
blocks. Gotcha.
Yeah. Never know.
Okay. So these are all those expansion plans for that half of the plant down there.
You may have whittled out some camcorders every now and then.
Couple little.
Is that a 60 mil?
So that's actually like a tractor cam cap is what that is. But yeah, I think it's actually almost 70 millimeters is what that thing is.
Does it get cut down after, or is it that long?
It's that long.
Really?
Yeah, supplier they had before, you had the machine at 2 hops. They didn't have a machine that had the length ours does.
But yeah, and you'll see in the back there, we got a whole pile of billets in the back, just ready to go in case we need to make them. But usually we got, 4 to 6 of these on the go.
So is this getting cut on one of these big machines? Oh, really?
Yeah, we get roughed in over here.
So that's one of the finished blocks right over there, and we got a bunch more sitting over there too. But that's one of the first ones that was made, actually. Just keep it for reference sake and because it's pretty.
Now, the understanding too, though, is I think like a little bit I know is there's a top fuel block is a shorter deck height than a top alcohol block. Same rough block, except deck height's taller.
So yeah, in top alcohol and pro mod, you're definitely allowed to do some different things. I mean, there's different combinations. There's different cam heights. Like there's a raised cam block.
Oh, that's right too, because you can do a raised cam, and you're not allowed to do that in the top fuel.
Which is kind of silly, really, because there's no performance advantage.
Right. It's just a maintenance advantage.
Yeah. Well, exactly. But yeah, the block has to be, of course, legal per NHRA specs. So that's what we've done here. Is basically just made a.
Did you guys make the sleeves and stuff here too?
No, that's a Darton sleeve.
Okay.
Yeah. Pretty much a standard deal. Everybody uses them, so no point in reinventing the wheel there. They make a good product, so.
Well, everybody used to use somebody else's blocks too, so that didn't stop you.
Good point. Maybe one day. We'll see.
Okay.
Main caps, we have most of the fixtures to make the main caps in there, and we can do other stuff, of course, too, but all the main caps for the blocks are done in there. Well, the only thing we don't actually do in-house here on those blocks is obviously the sleeves, and we don't anodize the caps here, but everything else is done right here, including all the hardware, obviously. That's our primary. That's our primary. As you can see, over here, racks and racks and racks. So along this entire wall here is pretty much all of our, there's parts washers, vacuum heat treat machines, the nitrider, there's a cryo temper box over there too.
Do you do your heat treating here?
Yes.
Okay. Yeah. Curious to see that back, because I know it's like, what is it, when it heat treats, it's got to go from within 50 degrees or something of the melting temperature of the aluminum to room temperature in something like 5 seconds or something.
Yeah,
Like,
I think it's about 7 seconds. It'll
okay.
come out, the door will open up, it'll come out, and it'll immediately submerge it into a bath.
Gotcha. Because what's the temperature? What's the temperature? Some thing, there was a certain for every second longer
And then we machine everything within 60 to 100 thousandths of the final machining spec. We'll heat treat it, we cryo it, where we take it to 350 degrees below zero, and then we vibratory stress relieve it, and then we'll go do the finishing passes.
Gotcha. So it gets cryoed too?
Mm-hmm.
Okay.
Yeah.
So it goes right from heat treat to cryo before it gets machined again?
Correct. And
Okay.
then it'll get one more up, and then we'll vibratory stress relieve it, and then we'll do the finishing off.
Okay.
We saw cut the decks off, before it goes into the first.
Yep.
And we do that so we can cut out a coupon. What we do is we actually heat treat a part of the original billet with the block. So when we give a customer a block, we can give them the heat treat report, not only of our recipe or to our spec, but to their actual block. And what we do is we actually machine a dog bone out of this coupon, which we'll do a tensile pull on it. And it's the thickness of that dog bone is the same thickness of the thickest part of the block. So we're actually getting the tensile properties out of the thickest part of that block and how it was heat treated.
Gotcha. Yeah, and I guess looking at this, and anytime when I've seen it rough, it wasn't jagged like that. It was still smooth, even though it was a rough cut.
Yeah. When we go in there, we mean business. We're moving some material.
Right.
What we have, these three are just getting ready to go into op 40, which is the last op. We'll bolt the main caps on. They just came back from hard anodizing, and then that's when the finished bores will be put in place.
Gotcha. Now, caps go on, torque down, and then you do line hone bore or gun drill bore.
Yeah, we bore everything right to size,
Cool.
even the cam tunnel and the
Yep.
main.
I'm going to call it unfortunate recipient of a block that wasn't heat treated correctly, and third or fourth run with it literally took out the middle three.
Oh, wow.
So completely apart. So just ripped out of there. And
Yeah, the owners.
it was that they did a heat treat through the whole thing and never heat treated it again, is the understanding, at least from the lab reports that we got by sending it to then get it analyzed. So it's like, hey, all this stuff's all good. This stuff's, no, that's a pop can. Like,
The owner's philosophy is, he says, I like to sleep at night. He goes, so when it leaves our shop, we own it. He goes,
Yep.
like Mark said, we don't send anything out other than hard anodizing of the caps, and that becomes a problem. We'll bring that in-house too. But, we do all the heat treat, like I said, the cryo. We got a metallurgy lab here. We can test anything. Tensile test, fatigue test, all of our own microscopic inspection. I mean, we got a spectrometer in there that you just bring us a stud and you don't know what it is. We can spark it and it gives us the whole chemical analysis of what the material is.
Wow.
So we can match it up. And we do the same thing for our inbound. We buy all certified, aircraft certified material, but we can cut a section off and make sure it matches as the spec of what it's supposed to be.
now what is hard anodizing the caps? What does that do?
Just surface hardness for it,
Okay.
just to kind of eliminate some of the fretting you get, when a main cap wants to walk.
Okay. Because I always wondered that, hey, you got the block and then it's, a lot of times it's the same material or whatever, but like, why is it?
Yeah.
So, but are these steel caps go on this?
We use aluminum.
Okay, it's still
Yeah.
aluminum, so just
Yeah.
that, yeah,
It's
it's
a-
like that extra process of anodizing it. What does that do that we didn't do it to everything else?
Yeah, it's
So-
a 7075, so it's a little bit different material than
Okay.
this. This is actually a 6061 forging.
Right.
So the 60.
Okay, so 6061 and then the caps are 7075? Okay.
Yeah, 7075 is a good material, but it's not really repairable. I mean,
Okay.
it's really hard to weld. 6061's a lot more receptive to repair work.
Well, and doesn't 6061 have some pliability and 7075 doesn't? It's more fragile? Like,
Yeah.
that's what I thought.
Yep.
for my limited education on this crap from breaking enough stuff.
All the manufacturing that you see kind of in the middle here, and as we get down to the end, this is all around fasteners.
Gotcha, all screw machines.
So head studs, main studs, rod bolts, head bolts. I mean, pretty much anything that's got some kind of head on it and a threaded end, we can make it here. So two different techniques that are primarily used: hot forging and cold forging. Obviously, they're pretty obvious. Hot forging is, I mean, you get that end of the part red hot, and then with a moderate amount of pressure, you stamp the head into it or whatever you're doing. Whereas cold forging, that great big black machine that you see in the middle there, I mean, it just does everything on sheer force.
Yeah, that's
So now the part comes out hot, but it goes in cold.
yeah. My dad made nuts and bolts like almost all his life until he retired, and it was all cold forging. Yeah. So he's missing a thumb to prove it. Yeah. That.
Yeah. Where do you work at?
So it was in Ohio where I grew up. It was like, yeah, just one of the small. He worked at like 3 different small plants that just made the different stuff. And last place I'm trying to think he worked at, but they made all the Allen keys and stuff like that, like all the good ones that everybody used.
So you can see there's a rod bolt in process right now.
Okay.
Pretty much everything's done on that, minus the threads. So it's had, I think it's pretty much done except for the threads, isn't it?
Yeah, we're doing the fillet roll.
So, oh yeah, fillet, yeah.
Now was this hot forged, cold forged?
That was hot.
Okay. So this was that material heated up and formed into this.
Those two machines basically down at the end there.
Gotcha.
What does the hot forging?
The end result of a hot forge or a cold forge part is the same. I mean, metallurgically, it's got the same properties, the forging process, though it's a little different because we're heating it versus a cold form. The metallurgical properties are the same. So it's really, when we hot forge something, we have to blank it. It's about a 25 to 30 second process. We got to heat it up when we forge the head. It's another 25, 30 seconds. You got about a minute per part.
So now was this material all this wide to begin with, and no materials removed? It's just compressed?
No, it'd be like this diameter.
Okay.
And then you're actually
and then you press that into it.
Yeah.
Gotcha. Okay.
So that does it in a single blow in a hot forge application. Cold forging, it does it. Our machine, it's got a series of dies. It transfers it from one to the next, so it's a progressive die, and it just keeps forming it.
Gotcha.
But you know, so there's several pieces of tooling involved in that versus a single tool in this. Put it in perspective, you got about a minute per part to head it in a hot forge process. That we can do about 100 to 120 a minute.
Okay.
So I mean, it's hauling the mail when it's set up and running.
So now, do these make the same pounding? I know the cold forge machine, anytime I was around my dad's plant, literally all you heard was hammer blows all day long. Just every part was boom, boom.
Yeah.
Like, and
The hot forge is a thump, but it's a light thump.
okay.
The cold forge is that big.
Like, because of brute force.
Absolutely.
Yeah, I mean, we actually had to isolate the Metrology lab from the rest of the building. I mean, it's connected, but it's isolated and on a separate pad.
Because of the shaking just from the cold forge?
Yeah. And even with that, you know, we can see when you're measuring, you know, hundreds of the thousands, you can see some blips in the data.
Wow. And this is the big coils, because it'll straighten the material out as it feeds into the machine. Here we can walk over there and show you. As long as you're not too tall. You can see the series of different dies inside the machine there. So it just starts on one side and keeps transferring the part over and over and over until it's complete.
Your dad probably feel at home seeing this process.
Yeah, but I mean, this is horizontal. I remember all his stuff, at least the picture in my mind, granted I'm a young kid, was vertical. I just remember him being super tall, like the machines were.
You can kind of see a couple of the different steps. There's more than that, of course, but you can see as it kind of starts out and then it works its way into a...
Okay.
Wow. So usually there'll be more variety of all the different steps.
Oh, gotcha. Okay.
Taking apart. Yeah, when this thing is hitting, it's you definitely know it. You can hear
Right.
it inside the offices for sure, and or feel it.
Feel like it's the heartbeat of the shop when everything's running.
Right.
Yeah.
Exactly. Well, like I said, my dad's plant, I remember it was a whole building full of those, and they're all just banging and popping.
So this elevator's got like 3 truckloads of material in it. When you look at the material, like it ranges from $2 to $3 a pound to $150 a pound, depending on the strength.
So it's just your typical dresser drawer. It just seems to carry a lot more load than your normal dresser.
Way more underwear.
Exactly.
So these are all the blanking machines right here. So they're basically taken from bar stock, what you see there. You kind of go over here.
Oh, okay.
Going in with bar stock, coming out basically is that. So that's kind of the first operation. X is in it, basic shape, dog on the end of the stud is done. It just keeps spitting them out there. Another part comes through. Just press the button, just push the button, right? So simple, right?
So is anything done different from this material to that material, or that's just wrapped up and stored over there, and this is just came in and there's not space for it? So it's over here.
What we do is we put all of our high grade material in the elevator.
Okay.
I mean, it's not as fast moving as our standard. This is our E190, 8740. Then we have our S220, which is the next step up. But all of our H11 custom age and like MP35 is what's in the elevator here.
Gotcha.
Literally doubled the size this past year.
Oh wow. Okay.
And now we're in the process of rearranging a lot of the equipment, putting some more flow to the shop because we're adding more capacity in.
Yeah, from the outside you can't see, like, I mean, maybe you can see a joint, but I didn't see anything. It looked like just one continuous building.
So this is secondary operations. Like this is where we'll do the head work on the rod bolt profiling.
Dang.
Everything goes in, comes through, and then comes back out the other end.
Oh, you just pour it in a bucket and...
Yeah, that's it. Just easy like that.
Like if you ever watch Survivor, this is that ball game where they drop the ball and then they got to keep the balls in play.
Exactly.
And this is where the P1 race shop is being built, or?
Yeah, exactly. I have burnout contests in here and stuff like that. So yeah, as we grow and expand a little bit, we're gonna obviously move into this area. Thread rolling is all done over here. That's what they're doing, is putting threads on parts. So all the different gauges that are set up here, as they're feeding them into the machine, depending on which machine it is, they're measuring a part every so often just to make sure that everything is doing what it's supposed to do.
And FYI, they don't make these threads the way we do with the tap in there. It goes through a rolling machine,
We roll the
and
threads
it rolls them right on there.
Yeah. They're not cut, they're rolled in there. So
We're forming the threads, and we do everything after heat treat. So you're doing some work hardening at the same time, so you're putting additional strength in the thread. The tolerance of it is super critical because we're centerless for grinding that, because if you overpack the dies when you're rolling the threads, they'll literally blow the dies up. So it's got to be within a couple hundredths of a thousandth to not overpack the dies.
But yeah, and that's the thing, like literally, because it is, well, that one doesn't have threads on it. But yeah, I mean, it's going to be harder inside the bottom of each one of those threads because there's the same amount of material there. All it did is compress it down. So when we make threads, we cut out the
removing
waste.
material. Yeah.
So the machines we use typically are always like 1 to 2 sizes larger than kind of like your hardware store fastener, because they're rolling everything soft, where we're rolling it hard. So to do the equivalent size fastener, we need something that's got a little bit more muscle behind it. And some of this equipment is like these flat die machines. They're built like in the 50s and 60s. You know, you can't buy machines as good as these days. So we find a good core, we send it out, get it updated, put modern day controllers on it, get the die blocks and the ways resurfaced, but they're just robust. You can't buy that good iron anymore.
Right. No, and that's the thing. I mean, so much of it, people are just looking for the old stuff because they don't make it like they used to. So
these are 3-die machines, cylindrical die, and then these are 2-die machines. You know, really the outcome is the same. The difference is we can control the process a little bit more, particularly on the harder materials. So you can actually put some dwell time when you're forming the threads, you know, kind of adjust the rate. You know, where a flat die, it's just getting it, man. You drop the part in and it's going to have threads on it. Typically going to be the top end of your 4 threads. Plus, the more machines you have, the less setups you have to do. I mean, I tell everybody we're like an oversized job shop. You know, I mean, the racing industry as a whole.
right.
Because
No,
you know,
it's-
nothing we're doing is long runs. I mean,
No, it's the same as like, I mean, you guys are accomplishing more with fewer machines, but it's like you go to Dart and you watch the process of a block. Well, it's 9 machines. Like,
yeah.
it goes in the first machine and this
For
part
each
gets
setup to
done.
do a certain
Then it
thing.
goes in the next one, and like each piece of the way to work it down through to where, I mean, obviously you guys are running way more phases in one machine up there than they are, where it's just literally, it's just pop it out and it goes in. But it's also why the lead time's so long. It's like, because it's like, well, we got to have,
They always say, well,
we got to start that run.
How long does it take to make the block? Well, only a couple hours.
Right.
But it's
Getting
got to
the
run
machines
through
on,
each
right,
machine
exactly.
and wait its turn. And
Yep. Yeah. Each machine, it's 15, 20 minutes for what it needs to do on that machine.
Yeah.
And then run that through 9 times. So,
or 100.
right.
Yeah.
We got dual disc grinders
Yeah.
for making our washers.
Okay.
Got 2 grinders, so you're making sure they're parallel and flat.
Gotcha.
So all the washer just get put
Wow.
right inside there, holds it in place, and then
Certain size washers, depending on what washers you're making. And then what's that do there?
It's a filter for all your grinding.
Okay. Gotcha.
clean.
Okay.
It just cycles through, rolls off there.
So it
and
just
off.
automatically keeps new
Yep.
membrane? Okay.
Yep.
Gotcha.
Just automatically feeds it, keep everything clean.
Oh. Also, when it's not draining, then hey, this is the same thing you got in your toilet. It tells you whether or not the toilet's got enough water in it. So when it gets too much in it, then it flushes and it moves that out of the way and you get a fresh filter. So works exactly the same as your toilet bowl.
Yeah, the warning light.
It
on
costs
the,
way more than a replacement toilet at Lowe's though. So
the warning light on the machine flashes. Shitter's full.
yep, shitter's full.
So, metallurgy and metrology, 2 different things. Metallurgy, kind of like what you think, the science of metal itself, or the chemicals and everything like that go into it. So, like Kevin mentioned earlier, in here we have the ability to pretty much test anything to do with the composition of the metal that we're working with. So, before we start machining it, during and after. So I mean, we're verifying the steel before we do anything with it to make sure. I mean, we're buying certified material, but
Right. You don't
You
always
don't know.
get what you bought.
so this way we know exactly what we're starting with and we know exactly what we're finishing with. So all these different machines, of course, are doing all kinds of different things to test. And like Kevin, like he said earlier too, we can
There
actually
you go. There's your
physically tell-
periodic table,
Yeah.
just so that you're sure what you're dealing with. So
Yeah,
it takes you back to
Go
it takes you
school.
back to like middle school,
Yeah, goes
and you're
back
trying to
middle school, high school.
figure it out. So
Pieces of the block, making a basically a dog bone, and we're pulling it apart.
gotcha. And what
So-
machine does that?
So right out here,
Okay.
so we can show you
Oh, that
here.
machine right there.
Yeah. There's a couple of different machines that we use here, but basically they're set up to do testing. So I mean, we'll put a fastener in there, and we'll physically pull it apart. We'll try to pull it apart.
And then record
And
at
it-
what?
Yeah, records everything about how much force it took, how much it elongated, failure points, everything like that is all recorded. Basically, these two machines work on that kind of stuff. So always, everything we make, we check. We
Gotcha.
typically
So whether
run
you make
about
the dog bone, you'll pull a dog bone, or if you make the bolt,
We'll pull
then you're
the
putting
bolt,
the
the
bolt with the nut
stud.
on there.
Absolutely.
And then,
Yeah. So sometimes we'll put a nut on it. Sometimes we'll thread it into an actual fixture as well and pull on it that way. Just
Gotcha.
depends on what we're trying to
in
test.
case
and
the nut was the weak point or whatever, the nut behind the machine
well,
was
and
the weak
like a
point.
rod bolt
So-
doesn't have a nut on it.
Right.
It threads into connecting rods. So that's where we'll thread it in there and do something like that. But that's the metallurgy lab, and then we can walk over to the metrology lab, which is basically the science
Can you turn
of.
this light off?
Oh yeah, we can hit the down there. Metrology is the science of measuring,
Okay.
basically.
So it's like meteorology, like it's looking at the planets. So, like we had the solar eclipse. So, oh yeah, yeah. What do you call it? Well, what's the science? Yeah, maybe I don't know. What's the science of meteors and looking at meteors in the planet?
Astronomy, I'd say.
That's got to be a meteor something. That's meteorology. No, that's still weather. I don't know. Hey, when in doubt, just make up a new term and then call it good.
That works. So in here, biggest machine we have in here is the CMM for checking the blocks. And we can do other things on here as well too, but after every single block that we make is made, it comes in here, gets set up on a fixture, and obviously we check lots of different points on
Gotcha.
it just to make sure that everything is in spec.
Sure does seem like you spent a lot of money and did a lot of things just for that to point at that. I mean, I could do that with a lot cheaper. So I got stuff to sell you because I can point at that for a lot cheaper than all
Yeah.
of this to do it.
It's just a lot more accurate though. But, and then a couple of things like this is actually one of our torque testers. So it actually, this is going to do a test just like if you were putting the part into the rod or the block or whatever. We'll make a fixture basically that goes here, and we're just driving it with a torque wrench, except it's all electronically controlled, and it'll just go in there and it'll rotate the fastener and it'll do whatever we ask it to do. I mean, a lot of times what we'll do is we'll torque it to a small amount, let it rest, torque it up, just keep going. We'll be measuring the stretch and everything like that as we're doing that. And once again, a lot like what I told you before, we'll build little fixtures where the fastener actually goes in and is held onto that end, depending on, you know, what we're testing, different materials, different fasteners, all those types of things.
So is this where you figure out though, like if you supply a set of rod bolts and you say, hey, torque them to 120 or 180, do you supply that data?
It's
or?
part of it, yes.
Okay, because I mean, I know that there's the golden rule of a 3/8 gets torqued to this or a 1/2 inch gets
Yeah.
torqued to this, but when you're building stronger bolts,
Yeah.
I mean, I think the torque spec automatically would change with that.
It does, and even the material the connecting rod is made out of also has an effect. You're also looking at how much you're changing the outer round of the part as you're torquing it up. So there's a lot of factors. I mean, obviously the biggest thing we're concerned about is the stretch on the fastener, because a specific amount of stretch based on the type of material that it's made out of gives a certain amount of clamp load. And that's what we're really concerned about, is making sure that we're giving an accurate amount of clamp load based on what the customer is asking for.
Okay.
So now, of course, there's multiple different ways you can look at a fastener. There's a conventional, you know, just torque it up this much stretch, and then also there's, you know, torque to yield fasteners as well. So we can do the testing here to determine exactly what the right amount of stretch or torque is for a specific conventional type fastener, or we can also find out the yield point of a fastener, and then of course do that type of analysis. as
So
well.
even they use Harbor Freight sockets. Just kidding.
Sure. But yeah, that's basically what we're doing here. Now, I mean, so much of torquing and the proper torque and stretch has to do with lubrication on the threads and the under the head. I mean, we've done recently here a lot of different testing on a whole bunch of different fasteners, and it is absolutely phenomenal how
Really,
much.
on the underneath the head itself. So when you go to tighten it up, and as soon as it touches, like depending on whether or not that's lubricated, will determine how well
Well, it's
it
all
torques.
about the friction factor, right? Because so much torque gets used up in the friction factor of the nut or the bolt on the part or whatever it is. So I mean, the less friction you have between said fastener and part that it's touching, the easier you'll get to that load number, right? So I mean, it just.
I can tell you, I've never lubed the base side of the head
It's extreme.
before torquing anything.
Well, but
So-
so here's one thing to remember is that, for example, if you have a stud, like a head stud,
Yep.
and a washer and a nut, it's extremely important that you actually put the washer on the part, like onto the stud, dry on the bottom side, but the top side where the nut is going to touch the washer, it has to have lubrication.
Really?
So
Okay.
typically what we tell customers the best way to do it is put the stud in the block, put the head on, put the washer on, and then put the lube on the fastener or the stud itself. Take the nut, put lube on the bottom side of the nut and in the threads as well, and thread it down. Because the problem is if the nut is lubricated or if the washer is lubricated on the bottom side, what'll happen is when you're torquing it down, sometimes that the washer can rotate when you're torquing. You don't want that to happen. You want the washer to stay put and the nut to rotate on it.
Gotcha.
So that's why lubricating the top side and the bottom side, top side of the washer and bottom side of the nut is very, very important, and not lubricating the bottom side of that washer. So, and it's amazing how much it can affect the load on the fastener.
Wow, because that's
That's
the
all
other thing
happens.
too, is I know that basically 2 to 3 motions to torque something. Don't make it 16 motions to torque it down.
Yeah, typically
like-
what you're trying to do is step it up, and it depends on the torque that you're hitting, but usually 2 to 3 steps.
Right,
3
but then
steps
never
and
go
up.
back and check it, like once it's torqued, then don't check it 3 times after that to make sure it's still torqued. I don't know.
Well,
That's
the only case
something
where
I was
that
told.
where
So,
the
like-
only case where that can be different is like copper head gasket with an O-ring or something, and you're clamping it down, and the gasket is kind of doing one of these.
Gotcha.
I mean, then you can go back. But typically, the best way to do that is torque it up, and then back the fastener off, and go back to your full torque again. So just like when you're retorquing a head gasket,
Yep,
if you just put the wrench on it and put it to whatever you tried to torque it to, the thing's not going to move.
Right.
Because the amount of breakaway torque is much higher than what it's actually loaded at. So, I mean, you should always back it off at least 10 or 15, 20 foot-pounds, somewhere in that area, and then go back up to your spec. And you can do them one at a time,
right.
just go through. But that's the proper way to do it for sure.
Sweet.
But lubrication
Mark
is
Campbell's
huge.
lessons to live by. So if it doesn't work, he'll warranty it.
That's right, exactly. If you follow our instructions, it will be fine. Makes that pattern. But yeah, draws all kinds of different pictures. You can stand here and stare at the thing for hours and hours and hours. Just like we're doing right now.
Some people have too much time on their hands.